Hi everyone, today I'm gonna teach you how to apply the arithmetic operations on binary numbers, and we're going to start with the addition. For the addition, you should know that we have something that we call carry. The carry is an extra one that we cannot write it, like we only need to write or to use one bit. So you either have like 1 and carry, or 0 then carry. Like you're going to deal with one of these scenarios when you have a carry. So let's start, and actually we're going to face one of these situations in this example. So firstly we have 1 plus 1. As you know that 1 plus 1 will give us 2. So we need at least 2 bits to represent 2. So we're going to have 0 here and then carry. Because as you know that this is the representation of 2. So 1 plus 1 it's 2. But actually we're going to take the 0 only, which is here. And then we have this one as carry. Then let's continue. 1 plus 1 again plus 0 will give us 0. And then we have a carry. Then 1 plus 0 plus 0 is 1, and 0 plus 1, 1. So here is our answer. We can actually check our answer by converting these numbers from binary to decimal and check the answer if they are similar or something is wrong. So this number is 3 and this number is 9, and as you know that 3 plus 9 is 12, and here we're adding 8 and plus 4, which will give us 12 actually, because here we have 1, 2, 4, 8, and adding these together will give us 12, so our answer is correct. Let's move to the next example. Here we're going to deal with the subtraction, and for the subtraction, like as we had for the addition carry, we have in the subtraction borrow. So I can't say that 0 minus 1. This will give me a negative result, so I need to borrow from the next number or from the next digit. So as we had the carry for the addition, we have here the borrow. Okay, so to avoid the borrow, we had we convert the negative numbers in binary system to 2's complement numbers, and we add the numbers together instead of the subtraction and dealing with the borrow. But sometimes you need really to know how to do this the subtraction, because it's important in the division part. So let's start solving this example. Now we have 0 minus 1. 0 minus 1 will give us a negative result, so we're going to borrow. So this one will be 0, and here we have 2, so 2 minus 1, it's 1. Then for this part, it's also going to borrow, so 0, and here it will become 2. Then this one wants to borrow, so this one will be 1, and here we have 2. Then 2 minus 1, 1, and 1 minus 1, 1, 0 minus 0 at 0. Also you can double check by converting. This number is 10, and here we have 3, and here is 7. So 10 minus 3 is 7, so our answer is correct. For the third part, we have the multiplication. The multiplication actually is very similar to the one that we used to do on like with decimal numbers. Each time, like, we're going to take the first digit, multiply all digits of the first number, and then you add an extra zero, then you multiply, then for the third number you add 2 zeros, and so on. So let's start doing this. 1 times 0, 0. 1 times 1, 1. 1 times 0, 0. Then we add a 0 here. Then 1 times 0, 0. 1 times 1, 1. 1 times 0, 0. Then we add 2 zeros. 1 times 0, 0. Then 1 times 1, 1. 1 times 0, 0. And then we add all of them together. So 0, 1, 1, 1, 0. So here is our answer. And also you can double check by converting. Here we have 7 and 2, and this number is 14. So 2 times 7, 14. So our answer is correct. Moving to the last part, which is the division. I want you to pay attention for the division because it has some tricky parts. We're going to divide this number for parts, but make sure that this number is always greater than this number, just like we do with decimal numbers. As you can see here, if I took these 4 numbers and divide them by this number will be greater than this number, so I need to take another bit with them. So I'm going to take these 5 bits and divide them by this number, and because only we have a binary system, ones and zeros, so you either get 0 or 1. And if the number was greater than your number, like the number that you are taking here, greater than this number, so the answer will be 1. And then we subtract the 2 numbers and start from the bit that your least significant bit, from the number that you took here. This is our number that we're taking, and here is our least significant bit, 1, 1, 0, 1. It's really an important part here, because if you did any mistake here, everything will be wrong. So as you can see here, we need to apply the subtraction, so that's why it was important really to learn how to subtract binary numbers. So 0 minus 1, it's for this part we need to borrow. So here we're going to have 1, then also we need to borrow here. This will be 0, then this will be 1, 1, and 2. 2 minus 1, 1, then this one will be 0. No, sorry, this one will be 1, and this one will be 0, because here we have a 1, here we have 1 minus 1, and this one is already 0. Then we're going to take another digit here, and this number now is greater than this number. We're going to put here 1, as this number is greater than this number, and we're going to subtract them. So here we're going to borrow 0. The answer here is 1, and also we're going to borrow from here. So now we need to take this bit, but after taking this bit down, as you can see that the number here is less than this number. So before taking this one down, we're going to write here 0. After writing here 0, it's like we're taking the permission from this number to come here after writing here 0. And now we're going to subtract them. So we have here 0, and then we're going to borrow for this part 1 and 0, 0. So here is our remainder, and here is our answer. And this is the end of this video. Thanks for watching.